So next part is continuous spaces. Continuous random variables. Till now we focused on random variables that have a finite set of possible values, that is discrete random variables. So discrete random variables, they have a finite set of possible values. Real world problems. Continuous quantities such as weight, height, duration or cost that take real numbers. Continuous random variables. Probabilities over continuous random variables. For example, suppose that we want to reason about a random variable x that can take values in the range between 0 and 1. So there is a random variable x and this variable can take values between 0 and 1. That is, the value of x is the interval 0, 1. That means it can take values between 0 and 1. Assume each number in this range has equal probability. What would be the probability of a number x? Clearly, since x has some probability and there are infinite number of values, we must have that p of x equal to small x equal to 0. Goal. Finding the probability of a continuous random variable x. X lies in the interval a and b, where a and b are constants. So a was suppose 0, b was 1 and a is lying between 0 and 1. Probability density function. For a discrete random variable that takes on a finite 1 to 100 or a countably infinite number of possible values, set of natural number, we can determine probability of all values in the given range and is called as the probability mass function. For a continuous random variable, it is not possible to get the probability for each value in the interval. Instead, we will need to find the probability that falls in some interval. This is achieved by probability density function. So you have the PDF, that is the probability density function. Example. Even though a food chain might advertise a hamburger as weighing a quarter pounder, you can well imagine that it is not exactly 0.25 pounds. One randomly selected hamburger might weigh 0.23 pounds while another might weigh 0.27 pounds. So though it is saying that the hamburger is weighing 0.25 pounds, but it is not necessary. It will be weighing 0.25. 0.25 is just an estimate value. It can be less than 0.25, it can be more than 0.25. What is the probability that a randomly selected hamburger weighs between 0.20 and 0.30 pounds? So answer is, that is, if we let us denote the weight of a randomly selected quarter pound hamburger in pounds, what is the probability that it will range between 0.20 to 0.30? Now you could imagine randomly selecting, let's say 100 hamburgers advertised to weigh a quarter pounder. If you weigh the 100 hamburgers and created a density histogram of the resulting weight, perhaps the histogram might look something like this. So what is it saying? That the hamburger is weighing, some hamburgers are weighing close to 0.25, but some are weighing more than 0.25 and some are weighing very less than 0.25. So in this case, the histogram illustrates that most of the sample hamburgers do indeed weigh close to 0.25 pounds, but some are a bit more. So this is a bit more and some are a bit less. Now what if we decrease the length of the class interval on the density histogram? Then the density histogram would look like this. Now what if we push this further and decrease the interval even more? You can imagine the intervals would eventually get so small that we could represent the probability distribution of not as a density histogram but rather as a curve. The dots at the top of the tiny rectangle, and in that case might look like this. So if you go on further decreasing the interval, you will see that it is just looking like a curve with a density of 0.25 in the middle. Such a curve is denoted f of x and is called continuous probability density function. So this curve is called as f of x and it is said as the continuous probability density function. So this is the graph where f of x is there and your densities are there. You need to weigh the hamburgers which are between 0.20 and 0.30. And here in the middle you have 0.25. Now, what is probability density function? A function P R belongs to R is a probability density function PDF for x. If it is non-negative integrable function, so that integration of value of x p of x dx is equal to 1. The function P is greater than equal to x equal to upper limit is a, lower limit is minus infinity p of x dx is a cumulative distribution for x. By using the density function, we can evaluate the probability of other events. Example, p of a. So this is, suppose see, this is 2.0, this is 2.3 and you need to find for x. Will be equal to 0.3 upper limit, 0.2 lower limit, p of x dx. Let's see this example. Let x be a continuous random variable whose probability density function f of x is 3x square, 0x and 1. So you have been given this. What you have been told? What is the probability that x falls between 1 by 2, x and 1? How will you solve this? See. Probability, integration, lower limit, upper limit, 3x square dx. So you get 3x cube by 3. 1 is the upper limit, lower limit is 1 by 2. 3 cancel, x cube 1 by 2. So 1 cube minus 1 by 2 cube, you get 1 minus 1 by 8, which is 7 by 8. This way you will be solving this question. Now, straightforward integration you just have to perform. Next, let's see this example. Let x be a continuous random variable whose probability density function is given to you as f of x is equal to x cubed by 4 for an interval 0, x and c. What is the value of constant c that makes f of x a valid probability density function? So how will you solve this? You have been given f of x is equal to x cubed by 4. Integration 0 to c, x cubed by 4. Okay. Dx is equal to 1 by 4. 1 by 4 you take common outside, x raised to 4 by 4, lower limit 0, upper limit c. 1 by 16, x raised to 4, 0 and c. Upper limit is c, so 1 by 16, c raised to 4 minus 0, which is equal to 1. Because 1 is the maximum probability density function. So c of 4 is equal to 16. So your c is equal to 2 because 2 raised to 4 is 16. So c is what? C is 2. Uniform distribution. A continuous random variable x has a uniform distribution denoted ua, b if its probability density function is f of x is equal to 1 upon b minus a for two constants a and b such that a is less than x but it is b is greater than x. A graph of probability density functions looks like this. So this is what? This is uniform distribution. Uniformity is there. Note that the length of the base of the rectangle is b minus a, while the length of the height of the rectangle is 1 upon b minus a. So this base is b minus a and this height is 1 upon b minus a. Therefore, as should be expected, the area under f of x and the endpoints a and b is 1. Additionally, f of x is greater than 0 over the support a is less than x and b is greater than x. Therefore, f of x is a valid probability density function. Now, what is Gaussian distribution? A random variable x has a Gaussian distribution with mean mu and variance is sigma square, denoted as x is nothing but, so it is denoted, and it has a PDA of p of x is equal to 1 upon root of 2 pi sigma e raised to minus x minus mu the whole square upon 2 sigma square. A standard Gaussian has a mean 0 and a variance 1. So normal distribution, the continuous random variable x follows a normal distribution if its probability density function is defined as f of x is equal to 1 upon pi root of 2 pi, and in bracket you have minus 1 by 2 x minus mu upon sigma the whole square. Now this is your exercise. Let x be a continuous random variable with the following probability density function. First, what you have to do, you have to find c. For finding c, you will have to write minus infinity to infinity f of x is u dx. Your u is given as c e raised to minus u dx. C is common, e raised to minus x, infinity minus infinity, so EC is your answer. Next is to find the CDF of x. So find CDF of x. For finding that, again integration 0 to x. Why? Because we have to find for x. So integration will be 0 to x e raised to minus u du, which is 1 minus e raised to minus x. Thus, f of x, the whole x is this. Here we have to find from 3 to 1. So when you want to find from 3 to 1, 1 is your lower limit, 3 is your upper limit. E raised to minus t dt. So e raised to minus 3 minus e raised to minus e raised to minus 3 minus e raised to minus 1. So e raised to minus 1 minus e raised to minus 3.